Let's explore one of the most fundamental properties in geometry, the interior angles of a triangle. I'm drawing a triangle that's intentionally asymmetrical. This is important because we want to show that the property we're about to discover works for any triangle, regardless of its shape or size. Let's label the three vertices of our triangle as A, B, and C. Every triangle, by definition, has exactly three vertices where the sides meet. At each vertex, two sides of the triangle meet and form an interior angle. Let's highlight these three interior angles with arcs. We'll label these angles using Greek letters: alpha at vertex A, beta at vertex B, and gamma at vertex C. These symbols simply represent the measure of each angle in degrees. There's a remarkable pattern in every triangle. If you add up all three interior angles, alpha plus beta plus gamma, you always get exactly 180 degrees. This works whether your triangle is narrow, wide, tiny, or huge. But why is this always true? What's the mathematical reason behind this consistent pattern? That's the fascinating question we're going to explore. So far, we've established our triangle with vertices A, B, and C, and labeled the interior angles as alpha, beta, and gamma. Our goal is to understand the geometric principles that guarantee these three angles will always sum to exactly 180 degrees, no matter what triangle we draw. Let's explore a fascinating property of triangles. No matter what shape or size a triangle is, its interior angles always add up to 180 degrees. We're going to demonstrate this visually using a method you could try at home with a paper triangle. Let's highlight each angle of this triangle with a different color. For an equilateral triangle like this one, each angle measures 60 degrees. But remember, this proof works for any triangle, not just equilateral ones. Now imagine we're tearing off each angle from our triangle, just like you might do with a paper triangle. If we carefully remove each corner without changing the angle measure, we can rearrange them to reveal something interesting. Here's our first angle from point A, which we've torn off and placed at the bottom. Notice how we've rotated it so that one side lies flat. Now we're adding the second angle from point B, positioning it so it continues where the first angle ended. And finally, we add the third angle from point C. Look at what happens when we arrange all three angles next to each other. The three angles fit together perfectly to form a straight line. This is no coincidence. The angles create a straight angle, which is exactly 180 degrees. This visual proof shows